Today we're going to talk about resilience in building pipelines for MLOps. There will be a very short intro about who we are if you don't know us already. So we are an AI lakehouse, so a data system, a data platform for machine learning. We've been operating for 7 years, I would say, out of Stockholm. And we are in production in large enterprises, billion-dollar companies, unicorns in Germany, and so on and so forth. We do come from research. Not myself, but my CEO is an ex-associate professor at KTH. And we have a very long lineage, let's say, or history with MySQL and the like. So what do we aim to solve with machine learning operation? So evidently, the first problem is that we have no idea how models will behave in production until production. And this is mostly because people actually do not do the models in the production-like setup when they build the systems. And that's not like 20 years ago. That's actually a paper that was released last March. March last year, which still pretty much holds its own. So it's a meta study with the research and so on. And the second point is like, even if we would want to, most of the organization can't, because your current ecosystem typically does not support the AI workloads. So GPU management, real-time systems, and so on. So what we want to do is sort of define the problem and then see if there is a solution that can be applied to be more resilient. So the problem is in 3 scopes. One is ecosystem integration. And that's because your data doesn't come in the same form, doesn't come at the same time, doesn't come from the same type of systems, doesn't have the same cadence. So, some things can get updated every week, some things can get updated every hour, some things can be real time, some things can come from files and other streaming engines. So this is what you're supposed to resolve. You're also supposed to resolve a purely complexity of the engineering sort of ecosystem, new tools, new technologies, so on and so forth. And finally, the actual ops side of things. So, versioning, governance, lineage, monitoring, data and assets, and models. And then you have another layer, which is perhaps a bit different from the DevOps side, which is, well, you need to retrain. So you need to log that back into the system. And so you need to have a very, kind of cohesive solution for that. So do we need data pipelines or do we need an architecture? And if you look at the market right now, if you look at the big companies that actually provide the solution, they'll tell you, you need something like that. That's an architecture. There is some things here that are software, some things here that are practices, something here that makes sense, and some that makes a bit less sense. But more importantly, this is not a full ecosystem. You will need to replicate all that if you want to do real time. So it's not efficient enough as it is. And then you have other companies that will give you another mapping, and probably another company that will give you another sort of ecosystem, and so on and so forth. So the question is, is this MLOps really? Consultants, and I know there is a few, sorry, they might say yes, because they build by the hour. But if I look back at what I try to define, I'm like, well, does it solve the ecosystem integration? Does it solve the engineering complexity? Does it solve purely operational stuff? And maybe not that much anyways. So maybe we don't really need those sort of architecture. So how do we build resilience? Probably pipelines. So how does it look like? So you have your data sources, something happens, and you have a prediction. Problem solved. And perhaps. But so, the question is, okay, but what happens here? What happens between my data sources and my prediction? And typically, a lot of things. Data cleaning, pre-processing, feature extraction, integration, engineering, frameworks, and all. And so you can define that as more or less those 3 things. Feature engineering, training, and inference. And in some organizations, that will be sort of what you will have, a monolithic pipeline in the middle, a program that takes care of that. And then, you still need all those MLOps thingy in the middle. So, how do you manage updates, reuse? Does this generate conflicts? How do you monitor the systems in between? Where is the collaboration? Who manages the latency of the systems? So typically our insight as a data platform is evidently to break it down. So modularize that. You will have a defined pipeline for feature, a defined pipeline for training, and a defined pipeline for inference. And therefore, you solve a little bit of those aspects. So let's zoom in. Why do you want that to be separated? Is because everything here has a different use case and a different sort of practice framework and tooling. Here, oops, wrong button. Here you will need to actually handle the sources. Here you will need to handle the frameworks for training, perhaps the libraries, and typically in inference time, you also need to handle SLAs. Do I need that in a couple of milliseconds, or is it fine to wait a couple of days? Depending. So once you have that, you eventually need something else, because what you notice here in my pipeline thing is like there's actually no lines in between, because it's not really directly a relationship of like once you do the feature, let's move to the training. You actually need some sort of data management layer. So for some of you who have heard of Hopsworks and the field, feature stores, model registry, model serving, vector databases, data lakes, lake houses, that's all here. That's all here because those are programs and this is the actual data layer. And so you write and you read from it. And so once you do something like that, you can call it how you want. We call it an AI lakehouse. And we call it an AI lakehouse because the dominant framework today is essentially going towards open table formats. So you would want to be able to use iceberg tables, Delta, Hoodie, and what have you under the hood. You don't want to necessarily rewrite everything. You want to use what you have. So a lakehouse format. And so what you do here, once you have that, is that you can actually do things asynchronously. You have your feature engineering pipeline that is maybe connected to your inference pipeline because perhaps you need to do some feature engineering computed on demand. And you will have your feature engineering pipeline that may be connected to your training pipeline because, maybe those two don't really need to be connected. You don't need the training to directly feed the inference each time you do a pipeline. So that gives you a bit of that modularity. Obviously, this is a very high view of the thing, but it's a pretty good view. And if you compare it to the 200 boxes I showed earlier, that simplifies the life pretty much of the engineering team. So if you look at it a bit differently, and if you look a bit at what does it try to solve as well, you can look at it as a left to right sort of vision. This is the modern feature store here. That's what we tried to solve 5-6 years ago by doing feature stores. So an online data, offline data, and a metadata layer. And we tried to solve that for multiple reasons, one of which was the transformations. And so not all transformations are created equal, my CEO would say. And so what you do here in the feature engineering pipeline is not the same thing as what you do there in the transformation side. And that's because here you will do the aggregation, the transformation for your tables, but here you do the actual encoding. And once you do that, well, you can't really go back here. And so you add the new stuff, consistency, data validation, point-in-time correction, so on and so forth. But I'll get to that later. So at the end of the day, it looks a bit more like that. Because you need a real-time database, you need those OTF, you need these vector indexes, because it's all the hype right now. Oh, it was all the hype last year. You need views, so you need to be able to read from that without being destructive. You need to handle the metadata, and you need to log back all those predictions. So in practice, how does it look like? So I'll show you sort of a view only on that part. I think a lot of practitioners intuitively know how to train a model, but they don't necessarily know how to maintain the data pipeline that feed that model. So let's just have a sort of a small look there. So you have your data sets, data sources. It can be, a database. It can be a warehouse. It can be a CSV file as well for that context. Some of you have already seen this presentation, so sorry for the doubling. You will do your cleaning, your aggregations, and whatever. And then eventually you will have a cleaner table or any abstractions of your feature table that you will be able to feed to a model. That's your feature engineering pipeline. And ideally, this is programmatic, and ideally, you can divide it in different abstractions and aggregation. Now, what you need to do to go further, to go to the training side, is to have a proper mapping of all individual features from your table and all the transformations that you will apply on those columns to feed the machine learning model. And once you do that, you will have this sort of abstraction where you have the data engineering on one side, a bit of the feature selection, and all of that until here is your feature engineering pipeline, not until there. So all of that becomes a programmable item that you can run on schedule, that you can operationalize, and that is independent from your training pipeline. Now, once you need to do the thing, which is train the model and operationalize it, you will create a training data set, and it will create a model. So because you modularized everything, you will have this item here, which is a view over the table, which has all the features that you need, but the source data is never transformed. Well, you can actually do it a second time. So you can use a different subset of the data, like take different rows perhaps, without actually changing the underlying data. So you don't need to redo a full pipeline. And you can do it again, and so on and so forth, to your heart's content. So you can put 1,000 models in productions if you so require in those things. And so all of that becomes your training pipeline. Now, where is the MLOps? The MLOps is here because you can do very interesting things once you modularize. Once you have a training data set that is decoupled from the original data set, well, you can see the distribution change in your data. You can actually see the non-encoded data change, and you can monitor it. So you suddenly have feature monitoring. You will see when the model might require retraining, and you will know when the data is shifting. And so once you have that, you can also do versioning. And so the versioning of all the data is independent from every other version before. So you can roll back and say, well, we'll do a new version of that, but we don't want to break the underlying system. And that's ops, right? That's something in production. And that's where you start to do experimentation. You try new models. Maybe you try a new framework, but none of the underlying stuff breaks. So, much success. And then, governance and versioning. So once you have that, you can also have lineage, because all those boxes individually, eventually, this is all the items you need to take care of, or a part of the team needs to take care of. Perhaps the data engineering side of things might want to be more close to the source. Perhaps the data science side wants to be more close to the model and the training data. And so once you have something like that in a platform, such as Hopsworks, evidently, but once you have that in any sort of platform, you can have those things where you have the source, you can create derivation of your data, you can see which views may be not used, and you can create as many training data sets as you want, and you can see which actual model is using which data from where, from which version, and if you need to deprecate it. And that's MLOps. So that object here becomes sort of the interface between the training and the engineering. It also becomes the interface to the actual inferencing. So you don't need to have an actual different view to go and start to do inference, because here you have all the information you need. And typically you have all the metadata that allows reuse. So here, for example, this transformation, I think it's a scalar. Yeah, so it's standard scalar. It's applied on retrieval, not on the data itself. So if I need to apply a different sort of normalization or encoding to my model, it's all good. I'll just do another view with the same data, and I don't need to recreate new data all the time. And so that becomes much more easy to practice. So typically, you can retrain all that ad nauseam, and you can re-engineer all that to create proper, cleaner data coming from different sources, and so forth. So a different view. This is a bit raw, because that was for a presentation. That was an actual use case, but like a more like markety-ish view, I would say. So sorry, here it sort of crashed during the transition from Google Slide to PowerPoint. That's a point-in-time correct join. So you will have your feature groups. So that's the data source. You'll have your views. The idea is that you can apply filtering. So this is where, again, you can define, what will be fed to your model without changing the underlying data. So if you have a customer ID that, or like a geography or anything like that that you need to apply to your, or you need to train a model on, well, you will do it here. And so then this becomes the interface to the model. And that interface can have different sort of transformations, can have different sorts of maybe version. Maybe you will train on the whole data set, maybe just a subset because, I don't know, you do hyperparameter tuning, such things. And then you'll have all the version of the model. And that's an MLOps workflow, really, because at the end of the day, everything is modular, everything is its own component, everything has its own responsibility, everything should be versioned, and you can reuse and you can operate it. So ideally, you will have a faster iteration loop. So one of the things when you do this sort of thing, when you modularize and you have those free pipelines, so feature, training, and inference, is that you can work in a production-like sort of environment. So you don't separate where you do the experimentation and, let's say, the R&D to the production environment. It becomes the same environment. So you have a prediction problem, and you have things that you want to deliver from a customer. So you will do first the feature pipeline, then you will iterate from that, you'll create the training pipeline, and you will have the inference pipeline. All of them being independent from another, and you repeat. So if I need better engineering, boom, I redo the feature engineering pipelines, independent from my training and inference. Maybe I need better SLAs. I need to put in place a new tooling, a new system. So maybe I don't want to break all of that because I have an amazing model. I have an amazing engineering system. So then you do that independently. But if I do that in the same environment that where I'm going to be in production, that means I don't have to, pass over the ball and sort of have a system and another team taking over. It will be the same. It will, scale. So then you can have your MVPs, essentially minimum viable predictions or products already in production, and you can show value. Just a quick look on how does it look like in a maybe a bit more less, let's say less abstracted way, while using exactly the same systems. That's how it eventually looks. You have your feature pipeline. Here it's an LLM use case in that case, but it can be a more classic use case. You'll have your data sources. Each data sources come from its own feature engineering pipeline. Some need to extract text, compute embeddings, store them. And then you'll have your inference pipeline that also has its own complexities. And so here you kind of see the separation of concerns makes sense because maybe I don't want my RAG to be, tightly linked to my feature engineering and such. And maybe I want my logging to be completely separate to retrain my model. So at the end of the day, one system might look a bit more like that. I think I'm sort of on time. I knew I could do 60 slides in 20 minutes. I told you guys. So here you are. Yeah, thank you.
Thank you, Lex, so much. That's really, really interesting and inspiring. We are now going to open up for potential questions that you have to Lex. So if you do have one, just raise your hand and we will pass on the microphone to you. And don't ask your question until you actually get the microphone because we want to be able to hear you. Yes, we have a question over here. Thank you.
Hello, thank you for a really good presentation. Yeah. My question is, do you have anything with deployment of models? Because a lot of us, we already have a systems.
Yes.
But what about deployment and flexibility?
You mean us as a company or in general part of the system? How do you include the
us
deployment?
As a company and generally people
we do end-to-end. So we do handle model registry, model serving, and the versioning in there as well. So
when you say model serving, what exactly do you mean?
Well, actually providing an endpoint for a product to use the model.
How flexible is that? I'm sorry to ask.
Well, it depends how flexible do you need it to be. So if maybe you need to change the model behind it, but keep the same endpoint, you can. Maybe you need it to scale down and maybe not use it for a little while to save some compute. You can
scale up.
Scale down, like maybe less compute required to actually
serve the model. But if you need scaling up?
Yeah, as well. But then depending on your infrastructure. I think it's more of a vendor product thing. Happy to show you the platform.
Thank you.
But we do that. Scale to 0 as well.
Thanks.
Oops, sorry.
Thank you. Thank you for the question. Any other questions from the audience?
Any feature store question?
Yeah. Otherwise, I'm going to take the opportunity to ask a question from my own. So, for an organization or company that is completely new to this and wants to get going with this and wants to have a proper MLOps process, so what would be the first key area of your mind map that you would recommend them focusing on? Because there's a lot of different aspects here. Like, where do you start?
Yeah, you start by separating the feature, the training, and inference. Then, whatever data layer, data system you use, obviously we are the best, but you can choose something a bit less relevant. But your idea is to separate the separation of concern, the modularization, right? You don't want a tightly coupled system with a monolithic piece of code. You want separated concerns. So start by breaking it down in feature, training, and inference, and then it's fine.
Thank you so much. The next question over here.
Thank you. So I was wondering if I have some feature transformation or engineering step where it's not clear whether I should consider it to be a pure cleaning step or a part of the modeling. Do you have any general recommendation or approach on how to handle that? I mean, would you consider it?
So the feature transformation, the transformation that will be model dependent.
Yeah.
All the data pre-processing, aggregations, and so on.
So for example, if you have rows in the data with some features missing, I mean, you can view it as a cleaning step and just filter them out. But then some data scientists may want to model the missing points.
Yeah.
So do you just let the number of versions of the clean data explode, or do you?
No,
do you have a philosophy?
you separate. So the transformation that you focus for the model, the model-dependent transformation, does not apply on, let's say, the clean data or the original table. As soon as you do that, the number of features explodes. So you save it as a metadata, and you apply it on the retrieval of the data. So then you can reuse always the same original source to many models. And so that transformation is a user-defined function. It's a program as well. So you need to apply it at one point. Does that make more sense?
Yeah, maybe.
I can show you some code.
Sure.
I mean, maybe not now, but yeah, come up. Yeah. I'll show you some code.
All right, thank you.